Welcome to Snaps Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about position bias in recommendation system. This topic is based on a tech blog with the title Improving Uber Eats Home Feed Recommendations via Debiased Relevance Predictions, written by the applied scientist team in Uber. You can find the blog link in this episode's description. Throughout this episode, we will dissect the topic from both business and data science angles. Now let's dive in. On the business side, let's take a look at the problem to be solved. Uber Eats is a food delivery platform owned and operated by Uber Technology Incorporation. It allows users to order food from local restaurants and have it delivered to their doorstep. As a platform, Uber Eats earns a commission on each food delivery order placed through their system. So the more orders Uber Eats can drive, the more commission revenue they can generate. The Uber Eats feed recommendation is one of the primary ways the platform can influence and drive customer ordering behavior. It leverages recommendation systems to surface the most relevant and appealing restaurant options to users. Better feed recommendations can increase the likelihood of users placing orders, and this can drive order volume and eventually increases Uber Eats commission revenue. To achieve high-quality feed recommendations, the team prioritized to accurately estimate the conversion rate. The conversion rate here is defined as the probability of users ordering from a particular store after it is shown to the users on the home feed. The team uses machine learning models to learn from historical user interaction data and estimate the conversion rate for each store for this user at that specific moment of time. However, the interaction data itself does not always perfectly reflect users' preferences, as this data may suffer from a wide range of statistical biases. One of the most important biases is position bias. Position bias in recommendation systems refers to the tendency of users to engage more with items that are ranked higher in the recommendation list, regardless of how relevant those items actually are to the user. This bias occurs because users often focus their attention on the top recommendations or those on top of the phone screen. As a result, items ranked lower in the recommendation list tend to not get any engagement and attention from the user, even if they may be better matches for the user's interests. Position bias can skew the performance of recommendation systems, and it may lead to suboptimal recommendations and potentially missing out on relevant items that are ranked lower. So, addressing and mitigating the position bias is an important challenge in building effective and unbiased recommendation systems. Now that we've understood the business problem to solve, Let's shift gear and dive into the technology side to see what would be a good solution. First, although position bias is very common, it is still important to validate that such bias exists in the Uber Eats feed system and to know how significant it is. To measure the position bias quantitatively, the team designed the following experiment. They took a small portion of the Uber Eats feed traffic and randomly permute the order of the top recommended stores, and then serve this randomized top feed to the users. Imagine that in a world without any position bias, the users should have the same conversion rate for each of the positions. Because the top recommendations were randomly shuffled into this each position. However, the team did observe that the stores at the higher positions had higher conversion rate. And also, they found out that the behavior of the conversion rate decay along this position number was not the same. It is different across different user interfaces, platforms, or devices. This experiment validated the existence of position bias on Uber Eats feeds, and it also highlighted that position bias is different and could not be addressed as a simple decay factor. Knowing that the position bias exists, the next step is to think about how to mitigate such position bias. The team realized one missing step in the chain from an impression to an order, and that was the examination stage by the user. Let me explain what does the examination stage mean in the following example. Assuming that there are 3 fast food restaurants shown in my Uber Eats feed. The first one on top is McDonald's. The second one is In-N-Out Burger. And the third one is Chipotle. Here is how I, as a consumer, may think through this process. I first look at the McDonald's, but then I realize that over the past 2 days, I already had 2 Big Macs, so I don't want to buy it anymore. Then I move on to look at the In-N-Out Burger. The burger looks different, and it has great fries. So I just ordered from this store, and then the conversion happened. I did not even fully examine the third option, Chipotle. Although the Chipotle's burger could be a healthier lunch, my mind was already fixated on the burger choice. So Chipotle was not under my examination, and it would for sure not going to get any conversion. Now you see the importance to incorporate the consumer examination stage in the modeling. To achieve this, the team split their machine learning model for the recommendation system into more detailed components. If we call the observed conversion rate for each user on each store being the biased conversion, this conversion rate can be modeled as the multiplication of 2 terms. One term is about the true conversion rate. This describes the ground truth conversion rate if a store is well examined. The second term is called position bias. This represents the likelihood of an item being examined. Ideally, the team can use only the examined data to train a model and learn the true conversion rate directly. However, such examined data does not exist, and there is only the observed biased conversion data available for training. To address this challenge, the team built a deep learning architecture with two towers. The first tower models the true conversion rate, incorporating features about the user, the stores, and any other ranking factors such as historical click and conversion rate information. The second tower models the position bias component. It uses features like the position of this item being presented to the user, and some other informations like the platform and devices. This full architecture is trained on the real user engagement data. However, only the true conversion rate tower is used for making predictions and server traffic online. In this way, the model effectively factoring out the position bias component, and this model is considered the debiased conversion model. With this updated modeling architecture, the team found out that it did a decent job of extracting the impact of position bias from the training data. Through offline analysis on randomized traffic, it shows that the true conversion prediction of the position debiased model were not correlated with the position of the observations. Based on this encouraging offline simulation result, the team launched an experiment to compare this new position debiased conversion model against their existing production model. The experiment confirmed the promising offline observations, where they found out that users can place more orders from the home feed, and they rely less on the search functionality. Now we discussed both the business problem and technical solutions. Let's wrap it up. In this episode, we discussed what is position bias in recommendation system, how the Uber Eats feed recommendation team measured its existence, and how they built a modeling solution to remove the position bias and demonstrate the power to improve their final business impact. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.